Hi, I'm Tim Howland from Johnson Outdoors Minn Kota. In this video, we will show a replacement procedure for the control board on a Maxxum or Fortrex style motor. We'll use this Fortrex 80 to show a circuit board replacement on a cable remote steered model. But before we do that, let's show how to do a quick circuit board test with the board just laying right on the bench top. Now this is a 24 volt, 36 volt circuit board for a Fortrex 80 or a Fortrex 101 or a Maxxum 80 and 101 as well. To do a quick bench test on this circuit board, we'll need first of all a momentary continuous off switch to connect to the 3 leads that come from the circuit board. We'll need a push button with a magnet to actuate the reed switch, and of course here we have our potentiometer with the ribbon lead that we'll need to rotate as well, and our test light that we can use to show visual performance of this circuit board. We'll start by connecting the momentary continuous off switch wires in their proper locations. The yellow will go to the center terminal on the switch and the white and the green leads will go as shown here. So let's connect to our power source and then plug into the appropriate locations on the circuit board. B- being the terminal that's closest to the edge of the circuit board, and B+ to the terminal that's closest to the relay. Our output leads, so we will connect our motor minus up here and motor positive over here. So now with power applied to the circuit board, and this is a 24 volt, 36 volt circuit board, but we only have a 12 volt power supply here that we're plugging into. The circuit board will still be energized and we will still be able to see a variation in the light intensity even though this is a higher voltage circuit board. We'll place the switch into the continuous mode, and the first thing that we should hear is a slight click as the relay engages. The relay being located right here on the circuit board itself. So with the switch in the continuous mode, by turning the potentiometer, we should see that light begin to illuminate. And as we increase the speed selection setting with the potentiometer, we should see the light begin to increase in intensity from 0 to 100%. Now if we place the switch in the momentary mode, and if we turn the switch on, we can also test the function of the reed switch. So now when the reed switch is moved into close proximity with the magnet, the circuit should be either turned on or off. Now if we hold that in place, again we should be able to rotate the potentiometer and observe the light go from very dim to full intensity, from full counterclockwise, clockwise. So we've verified that this circuit board is functional, laying right here on the bench top. We will do a circuit board replacement just to show how that is accomplished on this particular Fortrex 80. The same procedure would also apply to a Maxxum or a Maxxum Pro from a few years ago. That same type of a replacement procedure is used for all of our variable speed motors. We'll start by removing the cover screws on the bottom side of the foot pedal. There are 5 screws that hold the cover plate in place on the foot pedal base, and 2 screws that go into the heat transfer bar on the circuit board itself. Again, you'll notice that the screws that are used to hold the cover plate on are a coarse thread cutting type screw, and the 2 screws that go into the heat transfer bar are a machine screw with a fine thread. With the screws removed, the cover plate will lift right off of the bottom side of that foot pedal assembly. And you can see the circuit board located right over here in this position. We'll start by just removing the wires And we'll maybe just take a quick minute or two to kind of notice where the wires are actually all routed, where they're positioned for reassembly purposes. Now we would be replacing this circuit board if in testing we found that the board had no output or the motor just continued to run at a continuous high speed. That's oftentimes how a circuit board failure will manifest itself, is that the motor will just run at high speed only or will not run at all. But of course you would want to verify that with a quick circuit board test prior to replacement. Now we will need to actually remove these two screws that hold the pulley in place, because we do need to access the rocker switch over on this side to disconnect the green, white, and yellow wires that go to the momentary continuous on-off switch. We'll also need to remove this cover plate. Now we'll need needle nose pliers to remove those 3 wires from the switch itself. We'll also disconnect the 2 leads that go up to the head of the control box that are used for the lighted directional indicator. So we have an orange wire and a brown wire, and a corresponding black wire with an orange stripe, and a brown wire that's connected to a black wire with a brown stripe. We will have to open up the foot pedal so that we can actually have access to our reed switch, our push button on-off switch, and the potentiometer. So let's start by removing the push button switch first. You'll notice on the push button switch there's a small tab here that we just simply depress with the thumb while pushing out, and we can then remove the push button with the magnet assembly. And you'll notice that there's a spring in place that normally sits right on that push button, and of course a corresponding standoff here on the foot pedal itself where that spring will be positioned when we reassemble things. Okay, with the push button removed, we can now use a small, this is a very small, maybe a 16th inch Allen wrench, to actually push up on the bottom side of that reed switch so that it comes out the top of the reed switch clip holder. So we can now move up to the top side here and we can see that switch coming out the top here. But we also need to remove the clip holder itself. So with the switch out, we should be able to push that right back out through the top side as is shown here. And now the wires can be removed through the slit on the side of that clip holder. And now the reed switch itself can be dropped out the bottom side of the foot pedal, routed out through the guide there and to the bottom of the foot pedal assembly. And now we'll need box end or open end wrench to remove that nut from the potentiometer. With the nut removed, the potentiometer can then be slid out and removed also from the bottom side. The circuit board now is free from the foot pedal assembly, and now the new circuit board can be placed into position. We can route that wire down in its proper location. It needs to go out through an opening here that's kind of in the bottom of that base, and we'll start by reconnecting that new potentiometer. We'll line up the D shaft here so that we can get things back together again. Extend that through, tighten that nut back into place, just finger tight at this point, and then we can use our 1/2 inch open end wrench to complete that tightening. And moving along, we can reroute those 3 wires that go over to our momentary continuous switch, and with those wires in place we can reinstall this cover plate, and we'll tighten those screws down right now at this point because we won't need to go back under this cover plate anymore. And we can use our wiring diagram that is included with every circuit board. And we'll always, as we indicated before, want to reference the wiring diagram that's packaged with that circuit board. So we'll kind of lay it out here, position the board and the wiring diagram in the same position so that we have the heat transfer bar towards me. And again, the same thing here on the diagram so that we can easily see that we're going to connect, first of all, green to this end of the switch, the yellow to the center, and make sure that you route that under the cable, and then the white wire will go at the on the remaining open terminal here. Okay. And then at this time we can reinstall this small cover, and then using the two small screws that hold that cover plate in place. And now again, following our wiring diagram, we will connect the B+ lead, which will be the black wire with the red stripe, to the B+ terminal on the circuit board. We'll connect the B- terminal to the B- lead. Now we can connect our brown and orange wires to the appropriate wires going up to the indicator light. So black with the orange stripe gets connected to the orange wire, and the brown wire gets connected to the black wire with a brown stripe. And those can be routed back here out of the way as well. Now, some people find it a help to actually wire tie some of these wires together out of the way so that they don't get pinched when the cover is reinstalled. Now at this time we'll also go ahead and reinstall or connect the motor positive and motor negative leads. So motor positive lead is going to be a black wire with a kind of a faint red stripe applied to it here. And that wire is going to plug in, according to our diagram, over here in this location. And our motor negative is going to apply or connect right here in the remaining open terminal. And now we have to route and connect our reed switch back where it belongs. So what we should have done is actually had that in position already, but I think we can still get there. Reed switch is now extending out the bottom side here, and now we need to route it through the opening in the foot pedal. And again, we need to take our clip holder, and the wires need to pass through the side of that, the cut side or open side. And the reed switch clip holder can then be slid into position in the foot pedal itself. You'll hear it click into place, and then we can position the reed switch itself in the opening in its holder. A good place to start is to press the reed switch down into position and leave it maybe about a 1/16 of an inch or 32nd of an inch or so up from the bottom side of the reed switch clip holder. And now we'll take our cover plate. The cover plate on the Fortrex and the Maxxum motors is about a 3/16 inch thick aluminum plate, and it's used to dissipate heat from that circuit board. That's why it's attached right to the heat transfer bar of the circuit board itself. A very important part of this heat transfer is to make sure that these rubber standoffs are installed. You will not have the air movement that's necessary to help keep the components of that circuit board cool. So it's very important that those 4 little rubber standoffs are installed. And now what we're going to have to do here is kind of line things up a little bit. And so what we'll have to do kind of is go through the openings here at the top side and get the screw holes somewhat lined up on our circuit board. So with that in place, I can start this screw, and I'll just snug it in place just to kind of bring that heat transfer bar up in position against the bottom side, or what in this case is the bottom side of that heat transfer base. We'll install the second screw, having kind of lined up the hole there with the needle nose pliers. And now we can install the 5 screws that hold the base in place on the foot pedal itself. We'll tighten those 5 screws into place, and then we will finish up by installing our push button with the magnet. So the magnet, again, when the foot pedal push button is depressed, when you're in the momentary speed selection position here, or operation position, the magnet moves into close proximity with the reed switch, and it energizes the circuit or turns the motor on. So we've got the spring into place, and now it's just a matter of popping that push button back down. And now we can connect things to power and verify that our circuit board replacement has been successful. Our power supply is turned on, and if we are clear of the prop, and we'll put it into the continuous mode first and see if we can get this motor to run. And again, because we are connected just to a 12-volt power source, the RPM is going to be relatively slow. All right, and now we'll check the momentary function as well. So we'll start with the speed selector setting at, we'll say, 30%. And when I depress the push button, the motor should begin to run. And this one requires very, very little movement of the push button to start the motor. So to adjust that, what we'll do is we'll take that push button out, and we will seat the reed switch itself just a little bit lower in the clip holder. We don't want that motor to turn on too easily, but yet we do want it to turn on with relatively little movement of that push button. So let's check that again now. So again, with the switch in the momentary position, about a 30% setting here on the selector switch. Now that's much better. The motor doesn't start to run until I've depressed that switch. A little further distance than it was previously.